So I want to welcome to the show a new guest all the way from Canada. I welcome Josh Lindal. Welcome to the show, Josh.
Thanks. It's still at 65%. Should I be waiting till I get to 100 here?
No, we won't get to 100 until we're finished.
Oh, okay. So it's just going to keep going until we get to the end. I see.
Yeah,
Makes
it will
sense. Okay, you
always
can cut
be
this part
between
out.
60 and 100. Yeah,
Okay.
I will. No,
I understand.
We will start it.
Yeah, thanks for having me on the show.
Yeah.
So you want me to introduce myself? Sorry, I got everything confused now that I distracted us with that.
We can go back a little bit. So I want to welcome a new guest to the show, all the way from Canada, Josh Lindal, or Lindal. I don't know how you American pronounce your Scandinavian last name, but anyway, welcome to the show, Josh.
Yeah, thanks for having me here. I do have a Scandinavian last name. It's Icelandic, but I think it's originally Swedish. So you probably know more Lindals in Sweden than I do in Canada.
It's a soldier's name, so a bit of a sidetrack. But in Sweden, we had this Olsson, Svensson. You got your father's name and you added son to it. But when you go to the military, everybody can't be named Svensson because that will cause confusion when your officers yell Svensson and everybody shout yes. So they started to give these type of made up last names to soldiers during their service, and some kept them. So what you have is an old Swedish soldier's name, probably. But sidestep from that.
That's very interesting. I always wondered why I have a Scandinavian name, but it doesn't end with son, right? Because all the Scandinavian names end with son. But mine, I believe it means exactly. Linden Tree Valley. So it's like a place name instead of a heritage name. So that's interesting. I'm learning something about myself on this podcast.
You're welcome. That's why we're here, to learn, explore, learn something about ourselves. So now you have an old Swedish soldier last name.
Interesting.
But you have a background in anthropology. Do you mind to share a little bit about what your research have been, and maybe some other projects that you participate in?
Yeah, so I'm a PhD student. Just yesterday defended my thesis proposal, so I can get down to my research, studying human tooth root evolution. And I also work at some archaeological sites in Serbia where we dig up the remains of Neanderthals and other human ancestors. And I also host a podcast called Screens of the Stone Age, where we review movies about mostly Paleolithic people, sometimes dinosaurs, anything old, really. So you can check out more of me there if you want to do that.
All right. And have you seen any Ancient Alien episodes in the past, or are you relatively new to this type of subject?
No, I've watched a lot of it. When it was new, I watched it all the time. It got to a point where it's like, they're not saying anything new. This is kind of boring. But I was in my undergrad when it started, and I was studying archaeology, and it was so interesting. I didn't really know anything about Von Daniken, so it was kind of a new idea. There's like Stargate and there's like the Raelism religion and stuff like that I'd been familiar with. So it's like a fun idea. It was really interesting to watch. I did watch a lot of probably the first 5 to 10 seasons. How many seasons are there now? Like 20?
It should be about 18. Depends on how you classify a couple of them.
I definitely would have watched this episode when it was relatively new. So I would have seen it before for sure.
19 episodes we are up on. Or seasons, sorry.
Mm-hmm.
And I don't think they have changed much because, as you say, after season 2, they start to just rehash it, but change a little bit. So they are not consistent in what they are saying between the episodes. You have Giorgio is an expert on saying one thing, and then do 180 say the same thing but completely different in another episode. So yeah, things change, but not that much. But how do you feel? This episode came out in 2011, aired in November. But how do you feel the information that was presented in the episode? Was it cutting edge in 2010, 2011, or was it rather old ideas?
It's an interesting mix. Some of the things they talk about, like their definitions of evolution, are actually not bad. They've got a lot of real experts on this episode where they've clearly like cut them out of context. But nothing that any of them say is really bad, right? It's like they've taken bits and pieces and then walked around them. But the things the experts are saying are more or less correct. There's a few things I think we'll get into that were already outdated by 2011 as far as I'm concerned, but there are ideas that still get, rehashed today. So in terms of the actual information from the experts, it's actually not that bad. It's just the crazy, fan fiction they build up around those stories that kind of loses the plot.
Yeah, it's a lot of that. And it's quite impressive because they seem to have struggled a little bit from the first season where they have a lot of real expert, and then they don't really have it in season 2 and most of season 3. And here they have quite a lot of real expert for some reason. Fiorella Terenzi from Italy, who is an astrophysicist, a musician, Craig Stanford, Ian Tattersall, and a couple of more. I'm not sure how they managed to trick them into this, but they did.
It's always amazing to me when people aren't familiar with something. And I think by season 3, I feel like just Ian Tattersall just didn't know what he was doing, because Ian Tattersall is a huge name in paleoanthropology. He's a well-respected expert in the field. And it just has to be that he somehow didn't know what it was. But like you said, there's no way that they're getting anybody like that these days, because everybody knows what it is, right?
Yeah, and most of these probably realized later on that they were cut way out of context and never did it again. So, it was one-time opportunity they got with many names. Learned that from season 1. But how about we get into the episode? So they open up the whole thing asking questions as they do, just asking questions. But the first segment is based on a discovery of a new species of humans, or how we should define it, by Lee Berger in 2008, Australopithecus sebida. I'm not great at pronunciations, but they seem to bring it up to show that some sort that we discover new species and there's something really extraordinary. But how do you feel as someone who look into all the Neanderthals and that? Do we find new species relative often, or is it a very special moment when we do?
Well, these days we're finding new fossils more and more. It's like the pace is accelerating, so it is really exciting. But one of the things about finding a new species is, like, species isn't a real thing. It's just like something we made up, it's just a way of categorizing things. So there's a lot of different definitions of species, and none of them are perfect. And again, it's because species isn't a real thing. It's a human way of classifying things, but nature just resists classification, right? So whether or not we find new species kind of depends on the opinion of the person doing the discovering. And there's kind of an incentive to name a new species, because if you find a species that already exists, you don't get top stories in the news websites and stuff like that. But if you name a new species, you get lots of attention. Therefore, you get more grant money because of that. So whether or not a new species is found, there's a little bit of baggage that goes into that. But we are finding way more interesting stuff more and more these days. They're talking about Lee Berger finding Australopithecus sediba in this episode. But today, Lee Berger is way more famous for finding a new species, Homo naledi, which they found in 2015. So if they had put this episode today, they would have done that one for sure. It's just the trendy new one that we found. And Australopithecus sediba is interesting, but Homo naledi is way more of an interesting find. So it is true that we're finding more and more interesting new species every couple of years lately.
Would you maybe want to give some of the highlights on Homo naledi, or I'm sorry again, pronunciation?
So the interesting thing about Homo naledi, there's actually a few things about this. It was found in South Africa. It was found in a really deep cave where there's some twists and turns that make it really hard to get in there. So very famously, they put out this worldwide call for small archaeologists. And they ended up with a team of entirely tiny little women. And Lee Berger himself couldn't get into the cave until this year. It was like 8 years where he couldn't even get in there because the passage was just too small and he didn't fit. And so by now they've cleared it out and he's been in there. But the cave was excavated by these tiny little women. They found 15 individuals of Homo naledi in this cave, which is a lot. They look primitive, so they look a lot more like Australopithecus than later humans. And they thought this meant that they were going to be really old, like 2 million years old. But it turns out that they were only about 250,000 years old. And that's really interesting because Homo sapiens, we were already alive at that time in South Africa, which means that we lived side by side with these humans. And that's really interesting. And that actually brings up one of the points they make in this episode, which is actually true, that throughout the course of human evolution, there have typically been many species of humans living at the same time. And it's actually pretty rare today that there's only one species of humans. That happened, within the last 30,000 years that all the rest of them went extinct. But from 5 million years ago up until the end of the Ice Age, at any given point in time, there were probably at least a half a dozen different species of humans living together. And they make that point in the episode, which is a true point. It's really important because it contradicts that linear progression of human evolution. People think about the march of progress where you have a straight line from a chimpanzee to a human. And that's not what it looks like at all. We used to use the analogy of a tree, and then it turned into a bush. And now we're finding that all these species were interbreeding. So we call it a tangled stream or a braided stream, where it's like a river flowing apart and flowing back together. So it's a really important point. It really changes the way we think about human evolution. But then they forget about that for the rest of the episode and totally use this wrong linear interpretation of human evolution in everything else they say after that introduction.
Yeah, and you bring up something very important, isn't that science really do change, and it changes quickly. For example, I have the Old Human Past, quite old edition, and here you have the tree version of human evolution, which, as you say, isn't really what they would teach in a course today necessarily, but something to keep in mind that the idea of evolution is not a stationary science, and it's changed a lot, and it's changed quickly, which I think many people tend to forget, and that we have this linear idea when we teach it, especially to children, to keep it simple, which makes some people have issues with grasping the idea of how evolution really works. Fun fact, I actually went to school with a creationist who took the course on human evolution.
I did that too. I didn't realize you had those in Scandinavia. I thought you guys had a great education system.
We don't have many. We have a couple. I managed somehow to end up in the same course, and he had to take it 3 times, I think, before he gave up and just wrote what the teacher wanted on the test while muttering, I'm not related to a goddamn ape or whatever. He later, I think, started to accept evolution, but that was quite a journey. So when we talk about evolution, do we have... there was something I wanted to say here. Right, something the show seems to struggle with is this idea of a natural selection within Darwinism. But they also talk about Desmond Morris, the naked ape theory, slightly. But he had more, that human evolution was based on sexual preferences. For example, we don't have hair because the people back in the days preferred men without hair on their body. And I actually heard the same idea about why Scandinavian people have higher lactose tolerance, that is sexual selection in play. But is there other
sexual selection for lactose tolerance?
So,
I've never heard that. I don't know why you need to make up a better selective pressure for lactose tolerance other than the ability to digest milk. That I've never heard that one before, but sure, I guess it's sexier if you don't throw up after you drink milk.
Or get gassy, you get all the ladies.
Yeah.
The one sitting by the fire. No, I actually had a professor that brought that one up. So, smart people can have interesting ideas from time to time too.
Mm-hmm.
But is there other driving forces when we talk about evolution, or is it just natural selection?
Oh yeah, there's definitely other forces. So when we teach it, we typically talk about 4 major evolutionary forces, or most textbooks are going to mention 4. Natural selection is one of them, and natural selection is just non-random mating is basically how we describe natural selection, or non-random reproduction, we should say. So natural selection just means that some individuals survive and pass on their genes better than others, and that's pretty fundamental to evolution. Another factor is mutation, that's where the variation comes from. So the variation that natural selection is selecting from comes from mutations, which just lead to different traits. And then there's 2 others, which are genetic drift. This is random change in allele frequencies, is the way we technically describe it. And there's a few reasons why that can happen. And then there's also gene flow. This is the flow of genes from one gene pool to another. And so gene flow is usually considered to be working against evolutionary change. Because if you have flow between populations, you're homogenizing them and you're preventing them from splitting into different species. And then you also have sexual selection, which is it is a real thing. It explains a lot of sexually dimorphic changes, like birds. Sexual selection is usually used to explain why male birds are often very colorful and female birds are more camouflaged. And artificial selection, which is humans influencing the non-random reproduction of other organisms, but sexual selection and artificial selection fundamentally are the same thing as natural selection. It's just non-random reproduction through whatever factor. And so if you consider members of the opposite sex and also humans to be just part of an organism's natural environment, then it's still really natural selection that's underlying those 2 things, right?
Yeah, exactly. And here we start to get some of the, evolution, the denialism within the show. For example, first of all, I have to mention they have not animation, but they seem to have hired some actors and dressed them up in what I think they trying to get is some sort of a primitive man costume. And it looks like, Planet of the Apes, but even more low budget version of it. And I'm not sure if they're trying to get Neanderthal or something out of it, but you should go and see just that part of the show because those costumes are amazing. But
I assume that the show is entirely made up of stock footage, so I would have guessed that they would have just like found videos that somebody else made where people were dressing up as cavemen, right?
I'm not sure. They seem to have enough budget by season 3 to send David Childress and others to different sites locally, so it's not beyond them to really dress people up and instead of going with the CGI animations that they buy for other episodes. I have to go back and see if there's maybe some actors named in the credits as the monkey people. But we get some interesting quotes around here when they're trying to prove that evolution is a silly notion, silly idea, because aliens are much more reasonable explanations for human evolution. We have Nick Redfern, who is asking why we don't see dolphins building cars or see elephants building houses, since, they have a large brain and thought as intelligent creatures. We have Giorgio Tsoukalos, who's wondering why we don't have fur if we went up to the north, where it's cold. That doesn't make sense that we would lose the fur and then go where there's cold. How would you talk to someone who is asking you these type of questions?
Well, when you study evolution, I mean, it's something that I've struggled with a lot because it's a really funny thing to be a scientist and study a thing that a large portion of people on Earth don't believe is real. And I mean, that can get to you because it's like I've spent 10 years of my life studying this. And what do you think? Do you think I'm stupid or do you think I'm intentionally misleading you, right? And I mean, if they're Christian, they probably think that I'm the devil misleading them. But I mean, if they like sit down and if you sit down and talk to somebody and you're not just like attacking, it's hard to imagine that somebody can be so evil, right? But also, it's got to be hard to imagine that somebody who spent 10 years studying something can be so stupid to have been getting it wrong for 10 years. And so the problem is that people tend to be pretty isolated and they live in their own bubbles and they never really talk to anybody who understands evolution. So like if you're asking me how to talk to somebody, the real thing is you have to, you know, not be on the defensive. You have to, you know, be friendly. You have to treat them like with respect and assume that they actually are smart, even though inside myself it's like, you are a moron and I hate you because you're telling me I'm either stupid or a liar. So it's really hard to do that, right? One of the problems in this episode is that their misunderstanding of evolution suffers from something that's really common among people who misunderstand evolution, and that's this anthropocentric bias, which I like to think of as main character syndrome, right? It's this idea that humans are somehow special and that evolution is leading up to humans and that everything that happens in evolution is about leading to us. And so when Nick Redfern says, I think you already quoted this, we don't see dolphins building cars and we don't see elephants building houses. The assumption is that these are the things that evolution is supposed to lead to, and if it hasn't led to that in anybody else, they're lagging behind, right? And he makes this explicit. He says, that might sound trite, but it's a fact that animals simply haven't progressed and advanced in the way we have. And he's using two key words there: progression, progressed, and advanced. Evolution is not about progression and it's not about advancement, right? So you can't take two animals and compare their level of progress or their level of advancement in evolution. Every organism is natural selection is making it fit its environment and its particular niche in that environment. So we assume, like, we start from the fact that we are humans, and then we make the assumption that we're special. And then we say, what makes us special? All the things that animals don't have, buildings and cars and houses. Therefore, if we take that and we say that must be our metric for what makes an animal special, then nothing else measures up to us, right? But you can start from the opposite perspective, and you can say, we don't see dolphins building cars, but we don't see humans being able to dive hundreds of feet underwater. We don't see humans able to hold their breath for 10 or 20 minutes underwater. So why haven't humans advanced as much as dolphins have? You know, why are humans lagging behind dolphins evolutionarily? Or we could say same thing about birds. Birds can fly, but humans can't. Why are birds lagging behind, or why are humans lagging behind birds, right? And so you can see it starts from this flawed premise that humans are special, where that's just not the case. Humans are just another type of animal adapting to a particular niche. And just one of the things that humans have done is we've adopted a generalized niche rather than a specific niche. And that makes us adaptable to a lot of different environments, which is one of the things that's kind of special about humans. But I mean, every animal has something that's special, right? So that's just our niche. There's nothing special about us. And they mentioned that Desmond Morris book, The Naked Ape, which one of the things this episode does is it pulls in these little tidbits of real science as if it's setting something up, and then it just kind of blows past them and forgets about them, right? It's like Desmond Morris wrote a book called The Naked Ape, which talked about why humans don't have hair, and then they went in a whole thing about why humans don't have hair that had nothing to do with Desmond Morris's book whatsoever, right? And I mean, that's the thing that Ancient Aliens does, right? It's the Gish Gallop. I'm sure you've used that term on this show before, right? It's this strategy of just throwing so much information at your audience that they don't have time to think about each piece of information critically because you've moved on to the next one already, right? But apart from the weird sexist, you know, the weird sexism in Desmond Morris's book, the main point of that book was that humans are apes, right? One of the differences is that we're hairless, but other than that, everything about us is just an animal. Like, we're not fundamentally different from animals. And the whole point of the book is that there is nothing special about humans. So they set up, I mean, if you watched the episode and you didn't know, you would get the impression that Desmond Morris was saying that humans are unexplainable in terms of biology, and they must have been created by aliens, but that's like exactly the opposite of what he's saying in the book, right? So
Yeah, that's.
I guess we can go on to the other thing. The hairlessness is one of the things they spend a lot of time talking about, right?
Yeah, we got it a little bit, but they went from this hairless ape to it's Giorgio Tsoukalos, the alien guy, meme guy, who wondering why humans would lose all their fur when we went up north where it's snowing and it's cold. And they do this because they have Desmond Morris, and how they frame Desmond Morris, as you say, makes him almost sound like an evolution denier. I even made a little note because I had to go. I was not familiar with Desmond Morris previously, so I had to go and look it up. And as you say, when you started reading about him, you realize that, yeah, he talked about a hairless ape, but it was not the main idea that we can't explain how we lost our hair. He has a quite interesting idea on how we lost his hair. I think his idea is sexual selection, basically. But Tsoukalos take this and then run that we can't have evolved from apes because it was cold, and why would we lose the fur if we go up north anyway? And something we come across right now was that, as you say, it's a field that is in constant change. And when I went and read my two university courses as part of my degree, we learned about the savanna hypothesis and a quantic ape theory and all of that. Would you maybe like to expand on these two? Because I think the savanna hypothesis is still a predominant idea many might have heard about. What do scientists mean when we talk about these different theories?
Well, basically the most important part of human evolution is the evolution of bipedalism, right? Because this is one of the things that differentiates humans from all other mammals, right? None of our close relatives in the apes or monkeys walk on 2 feet, not habitually like we do. Like chimpanzees and gorillas can walk on 2 feet, but they're not good at it. They don't have good balance. They're not energy efficient at it. So they prefer to walk on all fours. But of course, modern humans, we're obligate bipeds. We have to walk on 2 feet. We are much less efficient walking on fours. We're just not designed to do it, right? So that is the major thing, the first major thing that happened in human evolution when we split off from chimpanzees. And really, we don't know why that happened. That's still one of the big mysteries in human evolution. So the savanna hypothesis was an earlier hypothesis to explain why we evolved to be bipedal. And the idea was that chimpanzees and gorillas tend to live in jungles. They live in the trees. Most apes and monkeys are adapted to living in the trees. And therefore, our human ancestors would have been adapted to living like that as well, right? But at the beginning of the Pleistocene, the Pleistocene is the Ice Age, right? So the global climate gets colder, sea levels go down, we get glaciers building up in the north. But what happens in Africa is it starts to get a lot drier. And so we have a lot of woodlands receding and we have savanna spreading. And so there was an early idea that humans would have evolved to be bipedal, coincident with the spread of savannas. Because if our woodland environments were disappearing, we don't have trees to live in anymore. But if you can stand on 2 feet, you can see over tall grasses better. You can see farther in the distance to look for prey or predators. One of the things that happens on the savanna is you have a lot of sunlight exposure. So standing on 2 feet, and this is still true, it makes you a smaller target for the sun. So it keeps you cooling faster, right? And then the hairlessness comes into play here because if you're standing upright, you're a smaller target for the sun, but a bigger target for the wind. If you're hairless, more of that wind is getting to your skin where you can dissipate heat faster. And then a third thing that ties in with this is human sweating. Humans sweat way more than other mammals do. Most mammals sweat for chemical signaling. They send out scents to each other, which is why like dogs and cats smell each other, right? But most animals don't sweat as much as humans do. Sweating is actually pretty bad because you don't want to be losing all your water in a savanna, right? But what happens for humans is if you're hairless and you walk on 2 feet and you sweat, this makes you really, really efficient at losing heat. And so the savanna hypothesis says that when the grasslands disappeared, humans started to walk on 2 feet and they evolved to be hairless and they evolved to sweat more profusely all at the same time. And that explains where all of these things come from. And so this is still a good explanation for human hairlessness. Unlike Georgios Tsoukalos says, we do know pretty well that this is why humans evolved to be hairless, because we did evolve a lot in Africa where it was hot on savannas. And this is one of humans' real superpowers, is we can run like farther than any other animal, longer, right? Because we can cool down. Other animals can run really well in short bursts, but they heat up too fast and they have to stop and cool down. And most other mammals cool down by panting, which is the same method of cooling down as sweating, except that it's only the interior of your mouth. So you have to, you can't overheat as much in order to cool down. Humans don't have to do that. We can run and cool down at the same time. And so I think there's a famous race where every year a human races a horse over a long distance. And over a long enough distance, humans will always win because other animals are going to have to stop long before a human does. So that's all true. This is why we lost our hair. But it's not why we evolved to be bipedal. And because we know this because we've found more and more human ancestors that go back farther and farther in time. And the environments during the time when these humans were living at the sites where they were found, it's very clear that for millions of years, humans, the earliest bipedal human ancestors, were still living in woodland environments. So some of the contenders for early human ancestor are Sahelanthropus chadensis, which is found in Chad. That's the Sahara Desert right now. But at the time, it was a woodland environment. This was in the Pliocene over 5 million years ago. And so these humans that were first evolving to walk on 2 feet weren't living in the savanna. They first evolved to walk on 2 feet in the forest, and then the savanna spread later. Other contenders are Aurorantuganensis from Kenya, and then we have Ardipithecus ramidus and Ardipithecus cadaba in Ethiopia. And so all of these early ancestors were already bipedal, but they didn't live on the savanna. So the savanna hypothesis explains human hairlessness and human sweating, but it doesn't explain why we evolved bipedalism in the first place. So when Georgios says, I wrote down the quote here, he said, right after we shed our fur, we had to wear furs to keep warm. And he says, this is illogical. Yeah. Well, this is the other misconception that people always make with evolution, is that evolution has hindsight, right? So like in hindsight, sure, we can say this is illogical. Evolution can't see the future. It's adapting humans to the environment they're in right now. It can't predict where we're going to be in the future, right? So humans evolved in Africa, and they evolved to match Africa after those humans had already evolved to live in a hot, arid environment. Then they did migrate up into the north where it was an ice age, but evolution didn't know they were going to do that, right? So it doesn't matter how illogical it is. Evolution isn't a logical process. It is a matching you to your environment, not planning for the future, right? The other anthropologist there, Craig Stanford, he talks about hair loss as a chicken egg issue, and he says there's no way to ever answer that question. I think this comes from the fact that he seems to be an expert in living primates and not human evolution. Because right before he said that, Ian Tattersall explained hairlessness. He said it evolved for sun exposure, which is true. So it's funny that they started with the true explanation that's like, yeah, we evolved hairlessness because it helps us cool down in the arid plains. And then Craig Stanford says, there's no way we'll ever know. And then George Asukasalo says, it's illogical. It's like they worked backwards. They started with the real answer and then got farther and farther away from it, right?
Yeah, but that's how you know it's credible. You get one expert to explain it, and then you have another one question it, and then you have Sukalos to give the real answer. So, you know,
that's the Gish Gallop. They throw too many things at you too fast, right?
Yeah, they have a lot. Yeah.
Well, I don't know if this got on the recording yet, but during the break in our recording, you asked about the aquatic ape hypothesis. So you want to get into that?
Yeah, we asked a little bit about it too. It was one of my professor's favorite claim to bipedalism, and you seemed quite shocked when I told you this. Would you maybe want to explain what the aquatic ape theory is and why we necessarily shouldn't listen to it?
Well, the aquatic ape hypothesis is another explanation for why humans evolved to be bipedal. And again, like I said, we don't actually know why humans evolved to be bipedal really well. And so like people just can't stand not knowing something. So like a bad explanation in most people's minds is better than no explanation, which I think is why these explanations are still popular. Sometimes in science, we just have to say we don't know. But I mean, we're working on it. Eventually we are going to know. And we're making so much progress in paleoanthropology these days. But we can know that the aquatic ape hypothesis is bad because when it comes to evolution, you always have to think about what the selective pressure is, right? If there's no selective pressure, evolution can't evolve because, again, it's not thinking about the future. It's just working with the conditions that exist in the moment. So the aquatic ape hypothesis is a model of human evolution that tries to explain bipedalism by saying that humans went through an aquatic phase, and this is why we evolved to walk on 2 feet. And so the idea is that we weren't like swimming underwater like mermaids or something, but we were living in coastal areas and we were foraging for marine resources like clams or stuff like that. And the idea is that first of all, we evolved to walk on 2 feet because if you're foraging in a coastline ecosystem, you have to be able to keep your head above the water. So as you walk into the water, you walk on 2 feet and you stand upright so that you can walk deeper into the water while keeping your head above the water and then look down into the water while being able to breathe, look for resources, and then reach down and pick them up, right?
Yeah.
And there's a whole bunch of stuff that ties into this. So hairlessness ties into this because some marine animals, some marine mammals have evolved to be hairless because this makes you more streamlined in the water, like most notably whales and dolphins, right? Also like manatees, right? So it explains bipedalism, it explains hairlessness, similar to how the savanna hypothesis does. There's some other more esoteric stuff you can get into here, like they've tried to use this to explain why humans get wrinkly fingers, right? So wrinkly fingers, a lot of people would probably assume this is just because your skin absorbs moisture and sort of expands and it wrinkles, but it's not actually what it is. It's actually a nervous response. When your skin gets wet, your brain tells your fingertips through the nerves to wrinkle up like that. And that's why your fingertips get wrinkly, but like the rest of your body doesn't get wrinkly if you've been swimming all day, right? It's just your fingertips. And it's because it's an evolved nervous system response. The reason is that when your fingers get wrinkly, it's like grip. It provides extra grip so that things don't slip out of your fingers as well. And so again, the idea from the aquatic ape hypothesis perspective is you're foraging for resources, you reach out and pick up a clam, you have better grip when your hands are wet, right? And so it ties all these things up nicely. Now there's a whole bunch of problems. Let's go back through them. Okay. So starting with the wrinkly fingers, we also get wrinkly toes, but we don't pick up things with our toes. So why did we evolve to get wrinkly toes if the point is for picking up clams out of the water, right? This is actually an interesting thing. Nobody has really studied other primates to see if their fingers and toes get wrinkly. The only other one we know for sure is the Japanese macaques that live in the water. You know, those Japanese water macaques? They do get wrinkly fingers. And so obviously the explanation is that most likely all monkeys and apes get wrinkly fingers and also wrinkly toes. And this is because most monkeys are arboreal and our common ancestor was probably arboreal. If you're living in the trees and it's rainy and wet, slipping and falling is going to be a huge selective pressure because you're going to die if you fall out of a tree, right? Picking up a clam and having that fall back into the water is not a strong selective pressure, right? So that doesn't really make any sense.
But can't you see the women on the beach side looking at the man picking up the clam, just not dropping it?
Yeah, it's so much sexier if you don't drop the clam. The clumsy men get weeded out of the population, right? That's the thing about sexual selection is it's a difficult one to rule out, right? So it'll explain things until we find the real explanation, then we abandon that explanation, right? The other problem is the hairlessness, right? So some aquatic animals are hairless, like whales, but notably most aquatic mammals are not hairless, like polar bears and seals and otters. And, all of these animals live in aquatic environments, but they didn't evolve to be hairless. And this is because hairlessness isn't really useful in aquatic environments unless you are a swimming animal like a whale that needs that hydrodynamics, right? If the idea is that humans weren't swimming in the water, they were foraging in a coastal environment, they don't need to be streamlined. So that doesn't explain why we would evolve to be hairless. If anything, we would evolve better hair like otters and polar bears that have sort of waterproof hair, right? So that doesn't make any sense. And so when you put it all together, plus all these early human ancestors that we're finding come from woodland environments. They're not from coastal environments, right? So, it's one of these just so stories. You know about just so stories in evolution?
Not familiar with it in evolution terms.
Just so stories come from Rudyard Kipling. He used to write these plausible but like children's explanations for why animals are the way they are, like the story that the dogs have a wet nose because on Noah's Ark the rhinoceros poked a hole in the wall and the puppy had to stick his nose in the wall to prevent the ship from sinking, and that's why dogs have wet noses. Or the elephant's child, why elephants have long noses, because a crocodile tricked one and tried to pulled the elephant's child into the water and stretched out his nose, and that's why elephants have long noses. In evolution, we call these just so stories. These are stories about like an explanation for why something is the way it is evolutionarily, but like it actually just doesn't make any sense. Like it doesn't actually follow any principles of evolution. It's just sort of a fun childlike explanation. So the aquatic ape hypothesis is an evolutionary just so story. It wraps up everything neatly, but it just doesn't. That's just not the way biology works, you know.
Yeah, basically. And I think we will skip over Wallace right now.
Oh, do you know what? I am actually a big fan of Wallace. I would talk about Wallace if you wanted to.
But I was thinking maybe he fits more within behavioral modernity. Adam and Eve second.
Behavioral modernity?
Right
I mean, if you want, you can cut it out later if it's too long.
Let's do Darwin, because that's a typical point, especially among creationists, that they attack Darwin, and we are putting Darwin on the pedestal, and also what most people know about evolution, natural selection. But in this episode, they bring up Alfred Russel Wallace, who they portray a little bit as opposite to Darwin, while if we look at the history, they are contemporary, and they have not really agreed. They agree on Darwin's ideas on evolution, but they seem to have two different ways to get there. As I get it, Darwin is more on an individual level, while Wallace maybe more trying to look at a whole species and their environmental pressures, and how they adapt to the local conditions. And you're a fan of Wallace, as I here. Did you think
Wallace is
Wallace or?
Well, what they're saying about Wallace is true, but I mean, I don't think they're fair to Darwin or Wallace in this episode, really. Like you say, creationists especially, or anybody trying to disprove evolution, they love to conflate evolution with Darwin, right? Darwin wrote this book 160 years ago. Like, the book he wrote is not the way we understand evolution today. He was one of the steps towards our current understanding of evolution. But the reason I loved Wallace is, like, so much of the scientists from this period are just like rich white guys, and it's really frustrating to hear about their story about how, they were like Darwin comes from a rich family. He was going to be a doctor, but like he dropped out of school, and then he was going to be a priest, but like he dropped out of like seminary school, and then he's just like bumming around, and he gets like some rich guy connection to be like, hey, you want to go on a boat for 5 years around the world to be our naturalist? And he's like, cool, I just get to free trip around the world on a boat for 5 years. Like, most people don't get that opportunity, right? No. Wallace's story is totally different, because he was kind of a poor guy, or like lower middle class. His father was just sort of like constantly getting into these get rich schemes and losing all the family's money. So he like worked with his brother as a land surveyor, and he was like studying plants and insects while he was out working with his brother, right, in the fields and stuff. And he like worked his way to his own education, and he also traveled to South America and to Malaysia later to study, and he had to fund his own research by selling specimens back to the rich guys like Darwin in Europe, right? So he just was so much of a harder worker than Darwin, I think. Not to discredit Darwin, because Darwin was a great guy as well. But in doing this research around the world, Wallace was living in Malaysia, and he had malaria one day, so he couldn't go out in the forest and look for specimens. But he's writing as he's sitting there through fits of malaria. And he came upon the same idea as Darwin, natural selection. He wrote it up in like a 7-page paper, right? But because he wasn't a rich guy, he wasn't accepted in the high society science. He's like, I can't submit this because it's too radical. I have to send it to somebody that I trust who can review it for me and see what they think. He knew Darwin was working on the same problem, so he sent it directly to Darwin. And Darwin was writing the same topic into a book. He'd been writing the book for 20 years at that point. This was like 1858, right? And this is, I love this story so much because both of these guys were so humble and so just like such great people. Darwin got this letter from Wallace. He's like, well, I got to throw out my book. This guy's going to think I stole his idea. So he's like, no, I'm going to throw out the book and let him take credit for it. And Darwin's friends, Charles Lyell, and I can't remember the other guy, Hooker, maybe. He had two friends. He's like, you can't do that. Let us take care of this, right? So they presented both ideas together as the Darwin-Wallace theory of evolution. And it's only in the 20th century that we dropped Wallace from this theory. But they both came up with the idea together independently. Yeah. And for the rest of their lives, they were great friends. They were, they spent time together. They worked together. They collaborated together. They dedicated books to each other. So they were extremely great friends. And of course, they differed in their scientific opinions of things, that's the way science is supposed to work, right?
Yeah.
But it is true that Darwin believed human evolution could be explained entirely by natural selection. Wallace had trouble getting there. And it's important to think of the context here because in the 1800s, we didn't have the mechanism underlying evolution, which is genetics, right? They both came up with the theory of non-random reproduction, but they still didn't have any idea what governed the expression of these traits. That came from Gregor Mendel, who was doing work at the same time in the Czech Republic, but his research wasn't known to Western science at the time. It was only in the early 1900s that his work was rediscovered and combined with Darwin's and Wallace's work into our modern theory of evolution, which is called the modern synthesis of evolutionary theory. So at the time, it wasn't really that radical to think that there might be some other factor at play because we didn't have all the knowledge about the mechanism. And I really think Wallace is such an interesting character because there's so many things he got into late in his life that either we'd be like, you're ahead of your time, or like, you're so wrong, right? So first of all, he was one of the world's first one of the first anti-vaxxers from that early 1800s wave of anti-vaxxers, which, I mean, time is cyclical, right? Because they had anti-vaxxers in the 1800s. Now, the thing at the time is we didn't know why vaccines worked, right? Yeah. Vaccination comes from the Latin word vacca. Yeah. So you were scraping pus off of an infected wound or off of an infected cow and then rubbing it into your own wounds. It sounds like a wrong idea. And Wallace was like, you know what? Science doesn't know why this works. We should be skeptical of this. So he was an anti-vaxxer, but he wasn't that wrong about it at the time, you know? Another thing is, though, he got into an argument with a flat earther because, of course, there was a wave of flat earth movement at the time, too. But he was fighting against the flat earther. And because he was he was trained as a land surveyor, right? There was this flat earther who put a bet to scientists, 10,000 pounds, that they couldn't prove that the earth was round. And Wallace was like, I know how to do this. I'm a land surveyor. All you have to do is find a canal with calm water that's very long, like several miles in a straight line. And he set up this thing with 3 targets that were exactly the same level above the water. And if you could sight down the center of those 3 targets, it was flat. But if the center one was too high, then the earth was round. And so he did this. He proved the earth was round. The flat earther said, no, I don't believe you did it properly. I need you to change those methods. So he did it again with revised methods, still proved the earth was round. Flat earther never paid out, but kept taking him to court for slander, financially ruined him. He said it was one of the biggest regrets of his life, getting into this argument with a flat earther. And the biggest irony here, I think, is, have you ever seen the documentary Behind the Curve? A recent documentary about flat earthers.
But I recognize the experiment, and they do the same thing in that documentary.
They do the same thing, yeah.
Disprove their own theory, and they're still arguing about it as
so getting back to the point.
Yeah.
So getting back to the point about how to communicate with people who disbelieve in science, it's not about evidence. You can't just show them true facts and they'll believe it, right? There's something else underlying it that's preventing them, right? So you have to reach people, at their worldview. What is it about their worldview that's preventing them from accessing this thing? And it's because, when you're invested in a worldview, when something threatens that worldview, you can't change that. You can't change your understanding of the world by just replacing it with new facts. Your whole sense of identity crumbles, right? And that's why education for, anti-science can't just be throwing facts at people. It has to be, figuring out what it is inside people's worldview that is preventing them from getting there, and then reaching them at their own level, reframing the scientific topic so that it fits with the worldview that they already have, so that you can rebuild it as you're deconstructing it, right?
Yeah, that's exactly what we've brought up in the past, and I think I and a couple of others agree with this notion, with approaching with a sense of humbleness towards the other side's experience and ideas, because I think that's a better way to meet a person, even if we should also have the opportunity of making fun of the ideas, not necessarily the person who says them, but sometimes even that. And something I notice in this episode, comes up in other episodes too, is that they again have people credited with credentials they don't really have. For example, we have this astrophysicist or astronomer, Philip Imbrogo, he's referred to in the show. He said something that made me react. He brings up there's no explanation for human beings. They shouldn't be on the planet. If we were evolved and changed by an extraterrestrial source from early primate ancestors, that's the only way, really. And that sounded strange from an astronomer, even for this show. So I had to go and looking up, and apparently he made up his credential as astronomer, and he even had made up things that he was a military veteran and all of that, and
Oh, the
studied at
Americans hate it when you
MIT.
do that.
Yeah, so he pissed off a lot of people doing that. He had book deals and everything, but all of that just disappeared because some author or some journalist just called his university. Hey, did this guy study here? No. Oh. Yeah, but that's happened quite a lot in ancient aliens. They credit people a bit weird from time to time, and something you should be a bit careful of. Always double check people in a sense. But if we go back to the episode, they bring up an article. If we should maybe talk on how to speak with the public, they bring up an article from 2004 that's called Accelerated Evolution of Nervous System Genes in the Origins of Homo sapiens. And in the show, they portray this study to claim that the human the evolution of the human brain is a so-called special event, that it happened in a very short time span, and I think they portray it that it happened in just 50,000 years or something like that. And is that something you feel that scientists need to be better at, on how we phrase our studies? Because it's quite easy sometimes to cherry pick different things and paint them up from a small portion of a study that can be quite complex in other sense to understand.
Yeah, I mean, it's a tricky one because you can't predict how people are going to misinterpret things. I mean, you can be careful, but no matter what you say, somebody can cherry pick your words and turn it around. So I mean, that caught my attention too when they say special event. And I had to look that up myself to be like, what do they mean by special event? And of course, they mean a special evolutionary event, right? They don't mean a special alien intervention. And that paper, it's I mean, it what it says is that evolution happened in humans to lead to our brains, which is like not even a surprising thing to say. Of course it did, because one of the unique traits about humans is we have big brains and we're smart. So it would be more of a surprise to find out that there wasn't a special event in human evolution leading to big brains, because then that would explain, like that would suggest aliens interfered if there was no evolution for big brains, but we still have big brains, right? So yeah, it's just the phrasing special event is, I suppose you could expect someone would take that out of context. But again, it was 2004. That's 20 years ago. By the time Ancient Aliens comes around, like people weren't quite as attuned to people intentionally misinterpreting your words. I think in the year 2004, scientists felt more like they were talking to other scientists, and they weren't, expecting bad actors to come in and build conspiracy theories over misinterpretations, right?
But that's something we see in news. Is that something you have noticed in reporting on evolutionary finds or new human species? Do you feel that the media portray the scientific studies accurate, or are they trying to sensationalize it a bit more?
The real problem is just the way the media works these days, right? Like you've always needed a catchy headline. Now you need clickbait. It doesn't even matter if people read the article anymore, right? But also,
Yeah.
we don't have science journalists anymore. Like journalism has been, cutting back on local journalism. Everything is written by AI now, so they're cutting out as much of the fat as they can, and that fat happens to be journalists who used to specialize in paleoanthropology. There's only one journalist who specializes in paleoanthropology that I can think of that I still see writing stuff regularly. And so yeah, there's the combination of you need a clickbait headline. There's nobody writing it who actually understands what the report says anymore. And I think where the movement is right now is that to fix this problem, scientists are writing as many of their own public articles as they can. There's a website called The Conversation, where specifically scientists write with the help of an editor to present their findings in sort of popular language that everybody can understand. I've written a few articles there. I think you just told me that you read one of my articles on that website. So I think that we just can't trust journalism anymore, really, because it's for the most part, journalism isn't trying to be manipulative like Ancient Aliens is. They're just trying to sell clicks, and they don't know what they're reading, right? They don't know how to read a scientific paper, so they're pulling quotes out of it that they think are going to work, and they're just trying to get their clicks and get their money for it. So unfortunately, it's fallen onto scientists ourselves to write stuff directly for the public, which I think is a good thing, because there's less room for a game of telephone where things get confused along the way.
Yeah. Do you think when publishing papers that the language that we use could be simpler and more accessible?
For the actual academic papers, yeah, that's something that I try to work on as well. But I mean, it's really tough because there's just so much language. There's so much technical language in the field that it exists to make things simpler for us. Like, so we don't have to explain what we're talking about. We use the specialized word for it. But if you don't work in the field, you don't know what that word means. So there's only so much you can do to make a scientific paper more accessible. I think, the whole publishing industry probably needs some sort of revision where, make the scientific papers more accessible and write them as accessible as possible, but sort of, maybe make it a requirement that you have a, a grade 8 level language version of it that you publish at the same time, and have them sort of linked together.
That would be great, and probably get more people interested and engaged in the scientific community. But let's talk about some interesting ideas. I got stuck with something from Bill Barnes, who is not an evolutionary scholar, but doctorate in medieval literature. And he is talking about human tool making and fire and creativity. And that's something I find a lot of interesting because older one was the oldest one when I went to university. But I, preparing for this episode, learned that, of course, things have come through Lomekwi 3 stones, quite recent find published in Nature, older and older one, and pre-Homo genus, as I understand it. Is that something you're familiar with, that type of stone industry?
I mean, at a sort of superficial level, stone tools are not really my expertise, but yeah, I think it's pretty well established at this point that Australopithecus was making stone tools before the genus Homo was. But there's a couple of interesting things about this, the idea of the origin of tools, which I think get lost in the conversation a lot, or at least have been in the past. But one of the things about tools is that stone tools preserve really well, but wooden tools don't, right? So when we talk about the earliest stone tools that we found, these aren't the earliest tools people were using, right? So chimpanzees and gorillas use tools, and other animals do. Like all kinds of monkeys use tools, crows use tools. And so, I mean, if so many of our close primate ancestors were using tools, it seems to me that human ancestors have been using tools from the beginnings of human ancestors, right? I mean, it seems like all apes have the capacity to use tools. And so the point at which we see stone tools is just the point at which we started making tools out of stone instead of other things. I mean, we could have been using sticks for a lot of the things that we do, and it just won't preserve. So like the oldest evidence of stone tools is not really that interesting to me because it's not the oldest evidence of tools. The other thing that's coming up a lot in the literature these days is whether we can trust that these old stone tools are what we think they are. Because once you get to the Acheulean and the Mousterian and more recent tools, they look very clearly like tools that humans made. But the Oldowan and these really early tools, they're basically just some rocks that were smashed together and they have some sharp edges. And so the question becomes, how can you tell if these rocks that were smashed together were tools and the point was to get a sharp edge for cutting, or did they just break naturally, or is there some other factor that led these tools to break? And one of the interesting recent papers that came out is looking at tool use in some cercopithecid monkeys, some macaques, I think, using stone tools to break open nuts. And so they're not modifying stones like humans do to get sharp edges. They're just taking a natural rock and smashing a nut to break it open. And so that's, again, tool use, but that wouldn't show up in the archaeological record because it just looks like a rock, right? But sometimes they miss and they hit the rock on their flat stone, their table stone. I can't think of the word I'm looking for here, but they put the rock on a stone and then they smash it with another stone. If they miss and they hit that rock against the other rock, the rock breaks. And it looks a lot like a human broke that rock on purpose to get a sharp edge. But the monkeys don't use the sharp edge. That was an accident. It was unintentional, right? So if we find a rock broken in the archaeological record that looks like it was broken to get a sharp edge, was it broken to get a sharp edge, or was it just broken because they were smashing a nut, right? Still tool use, but also now monkeys are doing it. So how do we even know it was humans doing it at this point, right? So the farther back in time we go looking at tool use, the harder it is to really understand what we're looking at, I think.
Yeah, and that's a fair point because, well, these tools are very crude and, well, it's hard to say what they're really used for by just looking at them. You can theorize, but it's one of those things that's hard to for sure say is what we hope that they are or postulate what they are. But from these tools we get to a pure lie if we should say it that, we start to talk about the FOXP2 gene, or Georgios Sokolow start to
Yes.
talk about the FOXP2 or the 4K box protein P2. And he claimed that this gene alone is responsible for language. And there's absolutely no evidence of origins. And there's not, it's impossible for this gene to have mutated from the animal kingdom, because humans is the only animal with this genome, except, as you might suspect, the FOXP2 can be found in all animals, definitely within birds. And it's just one of those things that it sounds credible, maybe, as long as you don't go on Google and start to look things up.
Literally on Wikipedia, it tells you that all vertebrates have the FOXP2 gene, right? So that one was like that's the worst bald-faced lie in the entire episode. He says it sets us completely apart from every other animal, and he says that scientists suggest that this gene alone is responsible for language. But he says it exists out of nowhere without any origin, is what he says. Absolutely untrue. It's exactly the same as other vertebrate FOXP2 genes. I saw your show notes, with the exception of 2 point mutations. It has 2 base pair mutations in it, which differentiate it from other animal FOXP2 genes. So that's like writing a book and having 2 typos in it. That's how different it is compared to other animals. So just complete lie on that one. But the truth behind it is that scientists or the media did call it the language gene, and it is implicated in human language, but it's not the only gene that's implicated in human language. And it is implicated in communication systems in other animals as well. But also, it's not only implicated in language. This is one of the things that we see when we look at genetics is a lot of genes are what we call pleiotropic. This means they have an influence on multiple different systems. And so the FOXP2 gene also has an influence in like heart and lung tissue. It's expressed in multiple different parts of the body. So it really doesn't make humans very unique compared to other animals at all, apart from 2 base pair substitutions, which do obviously have an effect, because humans have a bigger communication ability than other animals, but not in the way they're suggesting whatsoever.
Yeah, and I think here is where it gets a bit tricky with the more gene. Do you have any good resource where people can go and learn more if they're interested in genes and that type of stuff?
Oof. I don't have any real educational. I don't have any real educational background in genetics. I've never taken a course at university, so my genetics is mostly self-taught. I'm not going to pretend I'm an expert in genetics. I understand genetics the way I do from, pirating a genetics textbook and reading it cover to cover, right? And genetics is important in my research, but I'm not going to pretend to be a geneticist. Yeah. I think the main takeaway for people to understand, the main takeaway for people to understand genetics better would be that most people don't have any idea how DNA works, and this makes it really easy to abuse it in the media, because basically it's magic. You can just say anything comes from genetics, and people won't understand that that's not true. But the way that DNA works is basically it's a code, and that code is made up of sentences, and each sentence basically describes how to make a protein. And that's all of DNA. All of the coding portion of DNA is just a list of ingredients to make proteins. Those proteins can be structural, like collagen is a protein that makes up skin and bones, or keratin is a protein that makes up hair and fingernails, right? So that protein, the protein that a gene codes for, can be used to make the body. But a lot of proteins also have a signaling function, like hormones are proteins. And so a hormone is a chemical signal that gets spread around the body, and it allows body systems to communicate with each other. During development, there's a class of proteins that are growth factors or transcription factors or things that regulate growth of an organism. And so the FOXP2 gene is a transcription factor. What it is the FOXP2 gene encodes the FOXP2 protein, and that protein allows cells to communicate with each other about how to grow. So FOXP2, it tells the brain partly how to grow. It communicates during the growth of the brain, telling the brain how to grow. And part of what it does there, it helps us develop the portions of the brain that create language. But it's not a language gene. And anytime the media calls something the something gene, it's a lie unless they're talking about a specific protein. So there is a collagen gene and there is a keratin gene. There is no language gene. There's no violence gene. There is no intelligence gene, right? These things don't exist.
No.
And so that's what the first thing I would do for genetics is understand that if anybody tells you there is a something gene, that's a lie, or they don't know what they're talking about. In this case, I love looking at the specific words they use in this episode, because you can tell Giorgio has no idea what he's talking about. He says the FOXP2 is a gene that was found in our nucleotides. So the nucleotides are the base pairs in DNA, right? And so a gene is built out of nucleotides. Like a nucleotide is like a letter in the genetic code. So a gene is like a sentence in the genetic code. So a genetic sentence is written out of nucleotide letters. But to say that FOXP2 is a gene that was found in our nucleotides makes no sense. I mean, I can't even think of an analogy as ridiculous as that. I should have prepared an analogy. It's like saying the dictionary is found in our words, right?
But I think he selected that because nucleotides sounds like nuclear, and he likes to claim that things are connected to nuclear accidents and nuclear warfare and all of that. So I think he just got stuck for a cool world in the end of it. And it sounds cool just when you say nucleotides. Yeah, it catches your attention if you don't really know what it is. But that's how we get into our next segment, where we talk about Adam and Eve. Could the Bible be correct, and could the Bible be code for alien interference? Because I'm fairly sure that it's not really correct, but Mitochondrial Eve is a concept they bring up, that we all evolved from a single woman in Africa who are the mother of all humans. I also heard there's a version of 12 women in Africa. That is the origin for the whole human species.
Yeah, this is another science topic that's really easy to misunderstand, and most people don't do a great job of explaining it. Oddly enough, Craig Stanford explains it pretty well right in the beginning, and then they just blow past that and ignore it and misunderstand it anyway, right? So Craig Stanford says, he's describing mitochondrial Eve, and he says, that doesn't mean we're all descended from the same woman, right? Because that's not what it means. But then they blow past that and they talk about it as if we are all descended from a single woman, right? So the way this mitochondrial Eve works is, I think it helps to think backwards through a family tree, right? So if you start from yourself, right? If you go back through the generations, you have 2 parents, okay? But you have 4 grandparents, and then you have 8 great-grandparents, and you have 16 great-great-grandparents. And if you accept evolution, this means we're all related inherently, right? Everything's related. We're related to bananas, right? So everything is a cousin to some level, right? But if you keep going back through the generations, eventually you hit a point where there are more great-great-great-great-great-great-grandparents in your past than there are people alive on Earth throughout the history of humans, right? Yeah. And so obviously that doesn't work, but what it means is that several of your ancestors have multiple roles through essentially inbreeding, but it's not inbreeding because it's so distantly related, it doesn't make a difference, right? But what it does mean is that the farther back you go in time, the more likely you are to find ancestors who are like multiple ancestors. You can have a great grandparent who is a grandparent to some cousin of yours, right? So eventually we get to the point where everybody on Earth shares some of their ancestors. Okay. And so when we talk about the mitochondrial Eve, what we're talking about is mitochondrial DNA. This is DNA that exists in the mitochondria of your cells, which isn't your personal DNA, but it's the DNA of these structures in your cells which don't sexually reproduce. You get them from your mother through the egg cell that you inherited from your mother. And because they don't reproduce sexually, that means they're all inherited clonally. They all have identical DNA apart from random mutations. And because they're inherited clonally through the maternal lineage, we can just add up mutations that people that differentiate two different people, and we can sort of determine how far back they share a maternal grandmother, right? And so the mitochondrial Eve is just the grandmother that everybody on Earth shares. It doesn't mean that there was one woman and then everybody came from that woman. It means that there were thousands or millions of women, but this woman happens to be the first one that we all share as a grandmother, right? Yeah. There were other women alive at the time that we also share as grandmothers because we have, hundreds or thousands of great grandmothers when we go that far back in time. So it doesn't mean there was a single population and we all came from one woman as the grandmother of that entire population. It means that there were many grandmothers, but this is the first one that everybody on Earth shares. And if we go farther back, there would be more grandmothers that everybody shares, because keep in mind that mitochondrial Eve has 4 grandmothers. And because she is the grandmother of everybody, those 4 grandmothers are also the grandmother of everybody, right? So it doesn't mean we all come from one woman. It means that if you go far enough back, we eventually hit a point where everybody shares the same grandparents. That's all it means.
I think that's one of the best explanations I've heard when trying to figure out that one. So thank you very much.
Thank you.
For that one. And then we have another one of my... This episode was a strange realization that maybe I didn't have the best professor in my human evolution class, because I was struggling this 50,000 years number, because it comes up in the episode. Modern human is 50,000 years old, and I go back to Scar and all of that, but it's 400, maybe 200. And then I start to realize it's the behavioral modernity that they're talking about, when we as a human, not DNA or genetically, became modern humans, but more we have the fire, we have signs of cooking, signs of social structure, signs of an advanced mental stage that occur around 50,000 years ago. But do you feel that it's wise to have this distinction between modern human and modern or early human population?
Yeah, I basically wrote my undergrad thesis on this topic, so I do know a little bit about it. That was a while ago at this point, but so this was kind of the dominant paradigm about modern human origins going back to the 90s, right? There were a lot of people pushing this idea. Ian Tattersall seems to be subscribing somewhat to this idea in this episode, going back to 2011. And so the idea is that there's a disconnect between the archaeological record and the human fossil record. In 2011, we would have said that we see anatomically modern humans in the fossil record 200,000 years ago, right? Yeah. And now that's been pushed back as well, because the human fossils from Jebel Irhoud in Morocco have been redated to 315,000 years ago. And so now that's typically understood as the earliest anatomically modern human fossils. But in the archaeological record, we don't see the kind of behaviors that we classify as modern until about 50,000 years ago. And so this was an explanation to explain why there is this disconnect. And so the idea was that humans were anatomically modern and they looked like us skeletally by 200,000 or 300,000 years ago. but that we weren't mentally the same as we are today until 50,000 years ago. And in the most extreme versions of this, which I think Richard Klein suggested in 1995 or 2000 or around that time period, was that there could have been a brain mutation which significantly reorganized our brain structure, which led to a pretty immediate increase in our cognitive ability, and led to things like symbolic thinking and language and stuff like this. And of course, brain capacity doesn't fossilize. So this isn't coming from human fossils, because as we said, the fossils are anatomically modern 300,000 years ago. The biology doesn't change in terms of morphology at 50,000 years ago, but the archaeological record changes, especially in Europe. And this gets to the real crux of the issue here, because spoiler alert, most people don't subscribe to this idea anymore. But what happens is in Europe, around 40,000 years ago, we see a dramatic change in technology. It's called the Upper Paleolithic technology. So before this in Europe, we had Neanderthals living in Europe. They use what we call the Middle Paleolithic technology. It's a stone tool technology. It is made from what we call a core and flake technology, where instead of taking a stone and making one tool out of it, they turn that stone into a core, which is sort of like a little miniature factory. And if they strike that core in just the right way, they can take multiple tools off of it. So it's a very efficient technology. So Neanderthals were very good at making stone tools. But at the Upper Paleolithic, modern humans move into Europe and they replace the Neanderthals, and they're carrying a brand new tool technology, which includes stone tools using a core and flake technology. But those stone tools include a lot more blades. Blade is actually a technical term in paleoanthropology. A blade is a stone tool that is more than twice as long as it is wide. So it's tricky to get very long, thin stone tools. Neanderthals had stone tools, but they were more oblong most of the time, or spear points or things like this. Humans can get, or modern humans can get longer blades using their technology. But more importantly, they're using a lot of bone tools, harpoons, sewing needles, and art, especially cave paintings is what we see during this period. And so the idea was that because humans have cave paintings, therefore they have symbolic thinking, and therefore they have language, and therefore they're way smarter than the Neanderthals. And that must have occurred somewhere. And they say, well, this stuff just suddenly appears in Europe at 40,000 years ago. So there must have been a dramatic brain mutation that led to it. The problem is it suddenly appears in Europe because the modern humans just moved there. It was Neanderthals before that. So this is why it looks like a major behavioral revolution. The problem, as there's a paper by McBrearty and Brooks, Sally McBrearty and Alison Brooks, or Alison McBrearty and Sally Brooks. I can't remember which one. Alison McBrearty and Sally Brooks. Hopefully. From the year 2000, they put out this paper, and they called it The Revolution That Wasn't. And this paper is 111 pages long. And I read this thing front to back multiple times for my undergrad. What they said is you can't look to Europe to determine if there was a revolution, because of course there was. It's a whole different people moving in with a brand new technology. You have to look to Africa because that's where the humans were coming from. And so they looked extensively at the archaeological record in Africa to see if these same modern behaviors, the modern behaviors again are blades, cave paintings, jewelry, and bone tools. I mean, this is quote unquote modern. This is what we're defining as modern, right? They look to see if there's also a revolution in those behaviors in Africa, and there isn't. And so what we see is that this is a Eurocentric bias. The researchers doing the research live in Europe. Traditionally, this is where most of the scientists come from. The place where we're doing the work is mostly in Europe. So much of paleoanthropological research is focused in Europe because that's where the white scientists live. Africa is probably like 10 times the size of Europe or something like that, right? Africa's huge, but there's so much less research going on in Africa compared to Europe. And the research that is going on there gets overlooked, right? So when you look at, going back 300,000 years, we don't see a dramatic revolution 50,000 years ago. We see a gradual accumulation of technology over 300,000 years. And this is one of the things that takes people a lot to get their head around. They say, we today are so incredibly advanced, and it only took us like 200 years since the Industrial Revolution. What happened there? What happened is it takes a very long time for ideas to accumulate. But once they do, the growth is exponential. So if we go back
Yeah.
300,000 years ago, it takes 200,000 years to go from one tool type to another. But then it takes 100,000 years to the next, and then 50, and then 20, and then we have this exponential growth. And you can track that growth from stone tools all the way to space travel, and it just continues on this, exponential growth curve. And it's just hard to imagine how things could take so long. But it's just, ideas have to arise, they have to spread between people, and then they have to be passed down and preserved. And that's just the way it works. So as far as I'm concerned, this human revolution idea has been dead for 20 years. I think Sally McBrady and Brooks killed this idea, and I don't think that there's been anything to support it since then.
No, and it makes sense, and especially with the Eurocentrism is not surprising, and something we're still dealing with within archaeology in general.
Especially on Ancient Aliens, they love the
And
Eurocentric bias.
yeah, that's why they have their bread and butter, so to say.
Yeah.
And yeah, they always when people can't do things, they are a bit different skin tone compared to the people making those type of claims. But yeah, we are going to skip over Sumer and the Zachariah Sitchin's ideas because
that's fine.
We have covered them so many times and there's nothing new there. Basically, they have these.
I do love those Anunnaki wristwatches that they bring up, though, right?
Yeah, which is quite a normal Mesopotamian religious symbol if you would go and study them and not listen to Zachariah Sitchin, who claimed to speak all the Sumerian languages, but haven't been able to document any of such skills.
I love the fact that they're always wearing 2 wristwatches in those carvings. Yeah, they've got one on each wrist, just like people wear wristwatches. You got to have 2.
Yeah, but it's, one for their home planet and one for Earth time. So, when you think of your
right.
mother, it all makes sense. And they have the cool style, so you have to, look at the wrong end of your wrist instead of like normal.
Right.
Yeah, it's basically Anunnaki means those who Prince the Seed, because they were the kids of the big god Anu. So, yeah, logical. The short version. And then we get to the segment that basically made everything that they talked about moot. They started to talk about panspermia, so that life on planet was seeded, and they used this to try to bypass abiogenesis. So the life on Earth didn't evolve on Earth, but came with a meteor crashing down. And you have different schools within the ancient alien community. Some claim that the aliens, steer this comet or meteor to Earth from their home planet that was going under. A Noah's Ark, they put all the genes on the meteor and send it, and then it evolves. And others who just claim that, yeah, life is alien or it's just human that came with a meteorite. But Giorgio brings up something here that he claimed that we can't decipher 95% of our genetic material. And that was baffling because the Human Genome Project was on the way in 2011, as I understood it, that basically charted the whole genetic material of our genome. But he talks about junk DNA and that the aliens would stop messages within it. Is that a theory you feel is likely, or how did you feel about this panspermia segment?
There's 2 different parts to this. So like the junk DNA. So first of all, we don't call it junk DNA anymore. The fact about DNA that is really interesting is, I said before that DNA codes for proteins, and that's all it does, right? Well, the portion of DNA that codes for proteins is a very small proportion of the entire DNA sequence. There is a large non-coding portion of DNA. And so they used to call it junk DNA because it didn't seem to do anything, right? We now know that's not the case. We call it non-coding DNA because it doesn't code for proteins, but it does play a role in gene transcription. And so as far as I know, that role isn't fully understood yet, but it's not like there's nothing important there. It does something, right? So calling it junk DNA is a mistake at this point. It's called non-coding DNA because it's the portion of DNA that doesn't code for proteins, but it still plays a role in DNA transcription. DNA transcription is the process of, in the cell, the DNA gets copied and then translated into a protein in the ribosomes later, right? So transcription is the process where you copy DNA into an RNA molecule, and then translation is taking that RNA message and turning it into a protein. Now, your DNA in your cells is usually coiled up tightly. So in order to read it, to transcribe it, it has to open up. And the non-coding portion plays a role in opening up the DNA. Of course, the problem is if all of your DNA was being transcribed all of the time, that wouldn't work, right? You need to have some proteins being built sometimes and others not being built, right? So the non-coding portion of the DNA plays a role in determining when the DNA opens up so that the DNA can be transcribed properly. So it's non-coding, but it still is functional. And so the idea that there's a hidden message in there, fine, maybe, but I mean, DNA in a living organism is not going to be a good place to send a message because DNA mutates, right? The process of DNA replication involves mutation. So if you intended that message to be preserved for hundreds of thousands of years, it's full of mistakes by now. I mean, the longer you're expecting that message to preserve, the less of the message is going to be there. So it just doesn't really make any sense. Now, the other thing he says about how DNA, he says, not even with all the supercomputers combined in the world could we store as much information as we could on DNA. So I don't know anything about it, but I believe that there is some idea about how we could use DNA for storing information, and that would probably work if you're not putting that DNA in a living organism that has to reproduce, because of course mutation is going to happen. So it's not going to be a good way to store it. If you can find a way to write DNA and then read it without copying it with errors, sure, it'll store a lot of information. But the way he says this here is also really misleading. So he says, not even with all the supercomputers combined in the world could we store as much information as we could on DNA. It sounds like he's implying that human DNA contains more information than all of the supercomputers on Earth. That's not true. The human genetic code is only about 700 megabytes. It's not actually that big, right?
So you're saying
if he meant it in the sense
on a CD.
Yeah, you could fit the entire human genome on a CD. It's not that big. If anybody remembers what a CD is here, I don't know what the median age of your demographic is. I don't think I have a CD player even at all in my house.
What? I have a CD player and a vinyl record player, so
I got a vinyl record player because I'm a good hipster, but I have a box of CDs that I can't play. But yeah, so the idea with a supercomputer is that the genetic code, I mean, you have 700 megabytes inside every single cell, so it stores it in a tiny amount of space. So yeah, the physical storage space of DNA is going to be much smaller than all the supercomputers we have combined. But I mean, to say all of the supercomputers we have combined, well, you could store all the information on all the supercomputers we have combined if you made a bigger supercomputer, right? So he's clearly trying to make it sound like inside each human you have more information than inside every supercomputer. But no, you got a CD's worth of genetic information inside of you.
And the supercomputer isn't really
but then
the storage is
yeah, it's not the storage. Really. Yeah. So yeah, again, Giorgio, no matter what he says, he has no idea what he's talking about. He's just using buzzwords, right? But then the panspermia, I mean, that's fine. I don't have any reason to disbelieve in panspermia, but it's not an interesting question to me because, like you said, it just replaces abiogenesis. Where did life on Earth come from in the first place? That's a question we don't really know. I mean, there's the experiments of, I think it's Miller and Urey, like back in the 50s, to determine that we can create organic molecules from non-organic molecules under the right conditions, which might have been present early in Earth. That's still a big leap from that to life. So we still don't know where the first living cells came from. But it is true that every living cell on Earth has the same kind of DNA. And that does tell us that every living thing on Earth comes from one original living thing on Earth, which is true. And if that living thing was a single organism that came from space on a meteorite and landed on Earth and then reproduced and evolved, sure, that's fine. But what it does is it just passes the buck. Now, where did that living thing come from? Abiogenesis still had to happen somewhere. So it's just not an interesting answer to that question. But as you say, also, this destroys their argument from the entire episode, because now they suggest that aliens seeded life on Earth through an organism sent by a meteorite 4 billion years ago. And okay, great, but I thought that they modified an ape to turn it into humans a couple of million years ago or 50,000 years ago. They're kind of inconsistent about what they say. So are they saying that the same species of aliens that created us 4 billion years ago exists today with the same cultural knowledge, and also somehow they had the foresight to plan for something 4 billion years later, bearing in mind that the universe is only 14 billion years old? Why? That just puts way too much implausibility in here. So the idea that an asteroid, there is an impact on another planet with single-celled life, that single-celled life got blown into space and landed on our planet and spawned life on Earth. Fine. That's not an interesting idea, really, because, I mean, if life can evolve on Earth, it can evolve on another planet, and that's fine. Oh, by the way, the scientist that they talk about who has found cellular life in meteorites, he's been pushing this idea for years, but NASA has distanced themselves from him because they're like, he won't give up this idea, but it's got no support. So we don't want to be associated with this guy anymore. So, I mean, every so often we get a meteorite where like, maybe there was some cellular life in it. But as far as I know, there's no conclusive evidence of that yet. But again, it's plausible. I don't have any reason to disbelieve it. Although if we did find fossilized life in a meteorite, that doesn't tell us that it survived living in space. It just told that there's life on other planets, right?
Yeah,
and
that's Giorgio, and that's the episode. As we know, they can't really be consistent because the theories that they push out are not really compatible with each other to start with, but everything is better than the official story at one point or another. But so we know a bit more about human evolution. And do you have any favorite moment within this episode? Something that went, oh, this is a really good way to explain it, or this is really dumb?
I like all the stuff Ian Tattersall says. I mean, some of his ideas I think are a little outdated today. Like he seems to be a little on board with the behavioral revolution stuff, which would make sense at the time. Well, not really. Like I said, it was already out of date by the time, but it takes a while for ideas to die. Respect Ian Tattersall. Sorry he got sucked into this one. I like the stuff he says. To a lesser extent, Craig Stanford. He seems to know what he's talking about mostly. A little bit less knowledgeable about the human evolution. Lee Berger at the beginning they have in this. It's all stock footage. I can't imagine that he like they didn't interview him, so if he had to sign off on that, I imagine that he had no idea what he was signing off on either. Lee Berger is awesome. I can't remember what the thing was on Twitter. Someone was trying to talking about how archaeology doesn't have like a Neil deGrasse Tyson or a Bill Nye or a Carl Sagan, I think it was. And like someone was voting, like, I nominate Lee Berger to be like the Neil deGrasse Tyson of archaeology. I'm on board with that. Lee Berger is awesome. Very active on Twitter. I mean, Twitter is probably dead at this point. But if you can still tolerate being on Twitter, check out Lee Berger. He's always posting really cool stuff from South Africa. Yeah, that's the good stuff from the episode, I guess. Everything else is kind of just lying about everything those guys said.
So if people want to hear more from you, where should they go?
You can enroll in undergrad at the University of Winnipeg in the anthropology department, and I could teach you. I teach a fun course on archaeology and popular culture there. Most people probably aren't going to do that because it's a pretty small school. Otherwise, check out my podcast, Screens of the Stone Age. We review movies about people from prehistory, cavemen, sometimes dinosaurs. Not just debunking stuff either. It's fun to talk about why everything is wrong, and everything is always wrong, but we talk about the real scientific discoveries that were the inspiration for movies and stuff like that. I'm not on a lot of social media, but I don't think there's a single other human on Earth named Joshua Lindal. So if you want to know more about me, just Google my name and I'll come up.
All right, but I will let you go, and thank you very much for your time and your very good explanations on these strange ideas. I'm sorry for having you revisiting the ancient alien saga.
It's good experience, good practice. Thanks for having me. I love your show. I listen to it all the time. You were on my show once, so if anybody wants to check out my podcast, check out the episode on Atlantis where you were talking about pseudoarchaeology with us.
Yeah, the Atlantis movie. More problematic than you probably remember from your childhood. If you like that movie, stay away from that episode. But you also made one on bones recently, I saw. So you should definitely check out the screens from the Stone Age, of the Stone Age.
Yeah. All right, thanks.
Okay.